So next topic or unit is gear trains. So gear trains is nothing. For the transmission of power or motion, we need two or more gears, right? So that arrangement is called gear train. Earlier we studied gear terminologies and some design constraints, similarly interference, etc. Now we will go through the analysis of velocity analysis, that is our kinematics part, velocity analysis of gears. So we will go through gear trains. First, types of gear trains. So this is the first type, simple gear train. Now what is a simple gear train? You see this diagram, there are 4 gears, each gear is mounted on a shaft. So 4 shafts and 4 gears. So the definition of simple gear train, you know what is the purpose of shaft? Shaft is used to transmit motion. Shaft is connected to one gear and the output motion should be transmitted through a shaft only from the output gear. So here each shaft contains one gear only, right? So that is the definition of simple gear train. In a gear train where there is only one gear per shaft. Then what will be the other type? Then there are more than one gears in one shaft. That is called another type, that is compound gear train. Here you see, and the both figures are same. Second right one you see gear A. Gear A is connected to gear B, and gear B is not connected to not in mesh with any gears, but there are one more gear on the same shaft, gear C, and that gear C is connected to gear D. So you just imagine the motion. When gear A rotates, gear B will rotate in the opposite direction. When gear B rotates, here see B and C in the same shaft. So C will also rotate the same velocity. So same direction it will rotate. Then when gear C rotates, gear D will rotate in the opposite direction. So the definition of compound gear train, more than one shafts. It can be 2, 3 or any. Or that is a definition of compound gear train. Now third and fourth are, one is reverted gear train. Reverted gear train is actually compound gear train only, but it is a special type of compound gear train. Here you can see the left diagram. Output gear 1 is the input shaft. It's also called a driver or driving gear, and gear 4 is a driven gear. It's also called follower. Okay. So what's the nature of 1 and 4? Can you find any similarity between 1 and 4? That is the definition of reverted gear train. What it is? You see the shaft of 1 and shaft of 4, or the axis of rotation of 1 and axis of rotation of 4. The axis is same, right? The same line. So what we can say, the driver and follower, or the first and last gears are coaxial. First and last gears are, one second. See these two. First and last gears are coaxial. That is the definition of reverted gear train. In a compound gear train, when first and last gears or driver and follower are coaxial, it's called reverted gear train. Now you see again, gear 1 rotates. What happened? Gear 2 will rotate, but gear 2 and 3 are connected to the same shaft, so gear 3 will also rotate with the gear 2. When gear 3 rotates, gear 4 will also rotate. And finally, the last and important type is epicyclic gear train. Epicyclic gear train is the axis of gear is moving. When the axis of any gears in the train is moving, then it is an epicyclic gear train. A simplest type is shown here. So you see the axis B and wheel J. Imagine wheel J rotates. Imagine there is a shaft uh, along axis B, and then the shaft rotates. Wheel J will rotate. When wheel J will rotate, wheel I will also rotate. And wheel J and I are connected with an arm. That's here represented as a carrier. It is connected with a rod is used to connect wheel I and J. Now imagine if we are not fixing the output shaft, we are not fixing the output shaft, what will be the motion? Just imagine. Wheel I will rotate about its center, and also the axis A, that is a axis of wheel I, will rotate about B or rotate around your J. That for axis is moving. So such type of gears are called epicyclic gear train. Clear? So you can note down simple gear train, compound gear train, reverted and epicyclic gear train. So write all the four, and you have to represent diagrams. Also write the definitions. Definition should not like the write like this. You have to write a complete sentence for each type. Next is velocity analysis of different gear trains. First, you consider a simple gear train. I'm drawn a train A, B, C. There are 3 gears on each one, on each shaft 1, 2, and 3. Now you consider A and B are in mesh. Okay. Therefore, what we can say, we know in earlier case we studied an expression which connects speed, diameter, and number of teeth, right? So when omega 2 by omega 1 equal to T1 by T2 or D1 by D2, regarding our law of gearing, right? You remember that. So we can say omega is proportional to n, so anything applicable to omega ratio will be applicable to n ratio also. So what we can write, nb by na equal to dA by dB or RA by RB. Similarly, TA by TB. So that is a expression for mesh A and B. NB by NA equal to TA by TB, where NA is the speed of A in RPM and NB is the speed of B in RPM. Then BC. When we consider B and C, what we can say, NC by NB equal to TB by TC. So next step, you multiply both. So we multiply the left side, NB will get cancelled, so we will get NC by NA. Right side, TB will get cancelled, you get TA by TC. So what it is called, NC by NA equal to NC by NA equal to TA by TC. So what is NC? NC is the actual follower, right? The output, and NA is the actual driver or the input. So output speed by input speed equal to TA by TC. What is TA? Is the number of teeth on input gear divided by TC is the number of teeth on output gear. So it's equal to the ratio of input and output only. It's not, the speed ratio is not depending on the intermediate gears in a simple gear train. So you please note that. Then why we use such gears inside intermediate gears here is because when the suppose we have to transmit power from one shaft to another, and the distance of shafts is large. Just imagine it is there is a large distance between the both shafts. Then there are only two options. One option is to provide a very large gear. Another option is provide a number of intermediate gears. Okay. So we'll always, the economical option will be second, and that's why we are using intermediate gears. And one more use of intermediate gear. Here you see, if A is directly connected to C, A will rotate in clockwise direction and C will rotate in counterclockwise direction, right? So if you need to convert the, we have to transmit the motion only, not the, transmit both motion and direction, then you have to use one intermediate gear. Now here we use the B so that A will rotates in clockwise, B will rotates counterclockwise, again C will rotates in clockwise. So these are two uses of intermediate gears. Now remember, from in this chapter gear trains, we will represent gears with their pitch circles only. That's why a circular shape is drawn in each case, because for simplicity we are using we are representing a gear as a circle that's corresponding to the pitch circle. So write all these. This is for simple gear train. The last expression should be in box. Then you have to write also in words speed of driven gear divided by speed of driver equal to number of teeth on driven gear divided by number of teeth on driving gear divided by number of teeth on driven gear. That ratio in words also you have to write. So next is velocity analysis of compound gear train. Now you consider a compound gear train as shown. First you see there are 4 shafts, 1, 2 and 3 and 4. They are not clear, but just understand that first one is 1, second 2, 3 and 4. There are 5 gears, there are 6 gears such that shaft 2 and shaft 3 contains 2 gears each. Clear? Now imagine the motion. When A rotates, B will rotates in opposite direction. B and C are in the same shaft, therefore C will also rotate in opposite direction. Then as C rotates, C is connected to D, so D will rotate in the opposite direction. That means the same direction of A. Similarly, E and also connected to the same shaft, therefore in the same direction E will also rotate. So F will rotate in the opposite direction. F is the actual follower or the output, and A is the actual driver or input. Here some observations before the analysis. First one is, consider shaft 2, we have 2 gears C and B. Since the shaft is rotating and gears are on the same shaft, speed will be same. So in case of more than 1 gears on a shaft, speed of each gear will be same. That's I noted here. NB equal to NC and ND equal to NE. This is NE, not NF. Okay, this one is NE, not NF. Now we consider each mesh. First mesh is AB. In case of AB, what we can write, NB by NA equal to TA by TB. Similarly, in case of CD, what we can write, ND by NC equal to TC by TD. That is also equal to, I mentioned NB and NC are same. So you can write ND by NC also equal to ND by NB. Similarly, last case, between the mesh between E and F you consider, then you can write NF by NE equal to TE by TF. But NF by NE also equal to NF by ND, because ND and NE are equal. Now you multiply, as in the previous case you multiply all. So you will get on the left side NB by NA into ND by NC or ND by NB. So B will get cancelled. Here again multiply into NF by NE or NF by ND. So D will get cancelled. So but overall you have to do it in your book, so you will get clearly understood and you can clearly understand it. You will get it as NF by NA. NF by NA equal to what is on the right side, TA by TB. Second case TC by TD. Third case TE by TF. You cannot cancel anything because they are the number of teeth. Okay, not speed. So you have to write all those. So finally you will get like this. NF by NA equal to TA, TC, TE divided by TB, TD, TF. Now you see, what is TA? TA is a number of teeth on gear A, and gear is a driver. And TC, what is TC? TC is number of teeth on gear C, but you see gear C is also a driver, that is an intermediate driver. TC is also a driving gear such that C rotates, so C is a driving gear such that C rotates D. Similarly, E is another intermediate driving gear such that E rotates F. So TA, TC, T and TE are teeth of driving gears. Similarly, B, D and F are driven gears. So in generally for a compound gear train, what we can say is NF by NA, or output speed by input speed, equal to, that you have to write in words. Okay, output speed by input speed equal to is a ratio of product of number of teeth of driven gears, product of number of teeth of driving gears divided by product of number of teeth of driven gears. That is another very important expression. You have put that in a box. Both this expression and your words expression also put in a box. Then you have to do some problems. There are 4 problems in this section you have to do. So first problem, some gearing is shown. This is a compound gear train. As you can see, B and C are same shaft, E and D are same shaft, similar to our diagram, right? Yes. Okay. Then question is, motor shaft is connected to gear A and rotates at 975 rpm. So NA is 975 rpm. Wheels B, C, D and E are fixed to parallel shafts rotating together. The final gear F is fixed on the output shaft. What is the speed of gear F? So you have to find NF, the same expression. Okay, I think the same expression you can use. All number of teeth of all gears are given. So just substitute and find. That's a direct question. Next, problem 2 is, 2 parallel shafts 600 mm apart are to be connected by spark gears. One shaft is to run at 360 rpm, other at 120 rpm. Design the gears if circular pitch is to be 25 mm. Now what do you mean by design the gears? You can find the variables, that is number of teeth, pitch circle diameter and pitch, which is already given. So you can find the diameter and teeth of each gear, that's all. Okay, that you have to find. Now what are the given data? 2 parallel shafts. They mention parallel shafts and spur gears, that means your normal gear. Normally when you represent a gear, that is spur gear. They are 600 mm apart. Now from that what you can understand? 2 shafts are 600 mm apart. So where is the position of a shaft? At the center of one gear. Where is the position of the meshing gear shaft? Position of center of meshing gear. That means the distance between shaft will be the distance between centers of gears in mesh. So what is the distance between centers of gears in mesh? It will be the sum of their radius, right? So capital R plus small r, or R1 plus R2. So R1 plus R2 is 600 mm, or we can say diameter D1 plus D2 equal to 1200 mm. That is the first expression from this. The next one is, one shaft is rotated at 360 rpm, other is at 120 rpm. So we can write NA by NB equal to 3, right? So the ratio is 360 by 120. So that 3 will be equal to, if it is NA by NB, if NA by NB is 3, then it will be also equal to TB by TA. So TB by TA will be not T. We have D. We have an expression for D. So you put it in terms of diameter. dB by dA. Then you can write dB equal to 3 dA. So got 2 expressions for D. Right? Yeah. You have 2 expressions for D. So when you solve both expressions, you will get capital D and small d, or D1 and D2. Once you get D1 and D2, Next step is circular pitch is given. What is circular pitch? Pi d by t. You just substitute each d value and you will get both teeth values. Okay, another simple question. Then problem 3. Problem 3, the speed ratio of reverted gear train is to be 12. The module pitch of gears A and B is 3.125 mm and of C and D is 2.5 mm. Calculate the suitable number of teeth for the gears. No gear is to have less than 24 teeth. So here the speed ratio is given, that is 12. What is the speed ratio? You have to take NA and ND. A is your actual input driver gear, that's already shown, and D is the driven gear. What they given us is they usually use the word speed ratio to represent input speed divided by output speed. Okay, but in velocity ratio, text representing velocity ratio as output by input, so don't be confused. Speed ratio is 12 means usually input speed divided by output speed. So NA by ND equal to 12. That is a given data. Then module of between A and B, module is 3.125 mm and between C and D it is 2.5 mm. Okay. So where we stopped? Okay, it's forgot. Okay, modules are given. Speed ratio is given, so NA by ND is 12. Similarly, between A and B, module is 3.125 mm. Between C and D, it is 2.5. So MA and MB are 3.125. MC and MD are 2.5 mm. Then how will you proceed? So before proceed, you have to find the teeth ratio, right? So you know that NA by NB NA by ND equal to NA by NB into NC by ND, right? NA by NB into NC by ND. So you can write this 12 equal to NA by NB into NC by ND. Then each ratio you have to find, that it should be given the question. Okay, usually it's missing data. You can add in the question one more sentence. The reduction at each stage is same. Okay, the reduction at each stage is same. So that means between A and B and C and D, the reducing ratio of speed is same. Clear? Now you see, you wrote that NA by ND equal to NA by NB into NC by ND and it is 12. If both are same means each ratio will be root of 12. So you find root of 12, that will be NA by NB. That is also NC by ND. So and NA by NB can be written as TB by TA. So you will get an expression for teeth. TB by TA equal to root 12. Similarly, TC by TD or TD by TC as another expression. So you got one expression between A and B and between C and D. Now to solve all these teeth, you have to get another expression in TA and TB. Similarly, TC and TD. For that, you check this diagram. You check there is a 200 mm distance is there. What is that distance? That distance is actually the distance between shafts or the distance between centers. Between the center of B and A, it is 200 mm. Between C and D also, it's 200 mm. That means what you can write? What you can write, RA plus RB is 200 mm or RC plus RD is 200 mm. So you got another expression in radius or diameter. Diameter, what you can write, DA plus DB is 400 mm, DC plus DD 400 mm. Then you have to connect, you have to change R or D to T. How will you change? You need an expression for D and T. It is given, module is given, right? Simple. So module is given as A and B, MA and MB is 3.125. Then what you can write? What is module? D by T. Therefore what is D? Here we have dA plus dB equal to 400. And what is D? M into T, right? So MA TA plus MB TB will be 400. That is one expression. Similarly, you will get MC TC plus MD TD equal to 400, another expression. Now M values are known, so you get two equations, one in A and B and one in TA and TB and one with the TC and TD. So in total you have 4 equations. You solve all those, then you will get TA, okay, TB, TC and TD. That is the second question, third question, sorry. Then last question, reverted gear train. Figure is shown the next here, okay. This is the figure. So on reverted gear train shown in figure 3, two shafts A and B are in same straight line geared together. Then gears connected shaft A and C. Module is given. Both case module is given. Speed of shaft is about greater than 12 times speed of shaft B. And ratio at each reduction is same. Okay. So this sentence is missing in the previous question. So then find suitable number of teeth for gears. Number of teeth of each gear is to be a minimum but not less than 16. Also find the exact velocity ratio and the distance of shaft C from A and B. Now it is a similar question, similar to this. So you try to solve. With that, I will put the solutions by today. Tonight I will put all the answers so that you can check it as earlier you can check. Okay. Now that's all for now today's class. We have one more lecture remaining. So it's already about 30 minutes, so I cannot have one more topic with this. So I'll put it in another lecture. That's a very important one, epicyclic gear train. That I will have it in the next tomorrow's class.